this time, we use the return statement. So what is a return statement? It will cause immediate exit from the function, and this is used to return a value to the caller of the function. So again, remember that there are two ways a function terminates, and these two ways are: first, when the last statement has been executed and the ending close curly brace is encountered, like in this case, when this function input is called, the first statement to be executed is this one, and the next is this. So this is the last statement to be executed. Once that last statement is executed, execution for that function is terminated, and execution goes back to where this is called, and that is in this portion in the main function. And the second way is when a return statement is encountered. So what are the revisions that we did in the third program? Let's compare the second and the third program. So for the main function, we have this 3 function calls, and the same we have the 3 function calls. And in here, we declare rad and area to be local variables inside main function. So these are local variables inside main function. So what will happen? This means that the other functions, input, compute area, and output, can no longer directly access the local variables rad and area, since they are now declared as local variables inside main function. So for the third program, since rad and area are now local variables inside the main function, so inside the main function, we have local variables, rad, okay, say this is the rad variable, and we have area also. And these are local variables, meaning function input, function compute area, and function output, they don't have direct access anymore to these variables. No more direct access, okay? Again, why is that? There is no direct access for these 3 functions. All the functions in the program has no direct access to these local variables declared inside the main function. Okay, because that is the nature of local variables. The only function that can access or use local variables is the owner function of the local variables, or the function where these local variables are declared. And so other functions in the program like input, compute area, and output has no direct access anymore. So what happens is that we declare here a formal parameter r. So a formal parameter is like a local variable. So this is like a local variable declared inside function input. So it's like this function input has a local variable called r. That's r. Local variable inside function input is this one, r. And that is what we use in here, the r. So that, as you can see here, in the declaration for input, the function input now has one formal parameter r. And so as you can see, so notice that function input has one formal parameter, and a formal parameter is like a local variable inside the function. So this function input has like a local variable r, this one here. And compute area, another function, has again one formal parameter, which is this. And again, formal parameter is like local variable declared inside the function compute area. So in here we have, for compute area function, we have like a local variable r. This r here is this r here. And pi is a global constant 3.1416 defined on top of the program. So you can use pi anywhere in the program, or all functions in the program have direct access to the constant pi because pi is a global constant. And for the function output, it has two formal parameters, r and a. So in here, for function output, we have here two local variables, r and a. So the r here is this r in here, and the a here is the a in here used inside function output. So when we run the program, execution starts, remember, at the main function. So execute this function call, input. Now notice that the actual parameter, this is, in the function declaration for input, we call r a formal parameter. In the function call, in here, we call rad actual parameter. So take note that we pass the address, memory address of rad. That's ampersand. Remember from our previous lesson, ampersand is memory address. So rad is the value of rad in here, but ampersand rad is the memory address of this memory location. So what we pass in here is actually the memory address of rad, not the value of rad. So take note of that. What we pass here is the memory address of local variable rad. The receiver formal parameter, so execution jumps inside this function, and the receiver formal parameter here, which is r, is actually equal to this value in here. So when a function is called, there is what happens, a parameter passing. So the first parameter value of the function call will be associated with the first formal parameter in the function declaration. So this actual parameter here, the value of that is passed as the value of formal parameter r. So again, r here is called formal parameter, while rad here is called actual parameter. When the function call is executed, this line here, input ampersand rad, execution jumps into or inside the function input, and the value of the formal parameter r here is equal to the value of the actual parameter. So since what we passed here is the memory address of rad, r is equal to memory address of rad, which is this. So say for example, this is memory address 81. So say for example, in the RAM, this is memory address 81, and the value of this is no value yet. What we pass here for r is the value 81. It's a memory address. So it's like what happened here in the parameter passing ampersand rad actual parameter to formal parameter r inside the function declaration. What happened there is we are actually passing the memory address of rad, and we call that type of parameter passing as call by reference. Call by reference is a type of parameter passing in which the actual parameter passed is a memory address, not a value, but a memory address. So again, the type of parameter passing that happened here when input function is called passing this actual parameter ampersand rad or memory address of rad to the formal parameter r in here, we call that call by reference. And call by reference is passing a memory address. So if the memory address of rad is 81 in the RAM, say this is the memory location of rad, then what we pass here is 81, and the receiver formal parameter r in the function declaration for function input r is also 81. So this is also 81. Since the value of formal parameter R is 81, which is a memory address, then that makes R a pointer because its value is a memory address. So it's like R is a pointer to that location. So when this is executed, you have an output prompt to the user, input the radius of a circle, and then it asks for user input. Now, why do you think there is no ampersand in here when in the previous examples, we always put ampersand here? Why in this case, there is no ampersand here? What is the reason for that? Because R is already a memory address. R is a pointer. The value of R is actually from this part here. The value of R is ampersand rad. So it's like saying here ampersand rad, meaning whatever the user inputs in here as the value for radius, that user input value will be stored in the memory address of rad, right? Take note, remember that the value of R is equal to ampersand rad, or the memory address of rad. So when you say R here, it is actually ampersand rad, the one that you passed in here. So that user input value for radius will be stored in the memory address of rad. So if the user inputs the value 3, that value 3 will be stored in the memory address of rad, which is, okay, this part here, look at this, 81, right? 81 is the memory address of rad, which is this one. So this memory location will have a value 3. So that's how we assign the value for radius. And after that, the function call is terminated and execution goes back to the main function to continue executing the next line, which is another function call, calling compute area, and the value returned by this function call that will be assigned to variable area. After this is executed, the scanf inside function input, execution goes back to the main function to execute the next statement, which is this assignment statement. And in this assignment statement, the right side, which is this, is a function call, calling compute area, and the actual parameter we passed is rad, the value of rad, which is 3. So notice that when we call input, we pass the memory address of rad. When we call compute area, we pass the value of rad. Okay, so again, take note that when we call input, we pass the memory address of rad, this one here. But when we call compute area, what we pass in here is simply the value of rad. We pass here the value of rad. In here, we pass the memory address of rad because there is this ampersand symbol. And this one is without ampersand. So this is simply value of rad, while this one is memory address. When this is called compute area, execution jumps to this function declaration. So the R in here, which is this R in compute area, since we pass rad, rad is associated with the R here. The actual parameter is rad, and the receiver formal parameter here is R. So when this is executed, the function call, execution jumps inside this function, and this time the type of parameter passing that happened between rad and R is called call by value. Why is the parameter passing this time is called call by value? Because we pass a value instead of a memory address. So a while ago, when we call input function, what we pass as actual parameter is a memory address because of this ampersand. Between this ampersand rad and the asterisk R, the parameter passing is called call by reference because the actual parameter passed is a memory address, while in here the actual parameter passed is a value. And so the R in here, the value of rad will be passed to R So the R formal parameter of compute area will have the value of rad, which is 3. So this is now 3. This R in here inside compute area. And so this R is now equal to 3, which is the value of rad 3. And we use this value in here in the formula. 3 times 3 times 3.1416. The whole expression here is equal to 28.27, right? That's the value for 3.1416 times 3 times 3. And the return statement's job is to return this value to the caller. Okay, take note that pi is 3.1416. It is a real number. That's why the return type here, the return type in here is double. Okay, the data type in here must be consistent with the data type of the expression to be returned. So the value of this expression is 28.27, which is a real number type double. Okay, so it should be consistent. You cannot say in here integer because the value here is not integer. So it should be float or double. And preferably, it should be double because double is a bigger size real number. And so the value returned here is equal to this value, which is 28.27. So this is 28.27. And that is assigned as the value of area. So this local variable area now inside the main function has now a value 28.27. And after executing this line, we execute this last line in the main function, which is another function call, calling function output. And this time, the function call has two actual parameters. So the two actual parameters are rad and area. So take note that we are passing the value for rad and value also for area. When parameter passing takes place, when this is called parameter passing takes place, the first actual parameter here is associated with the first formal parameter in here, and the second actual parameter in here is associated with the second formal parameter here. R here is formal parameter as well as A. So R and A are formal parameters, while rad and area in here in the function call, they are called actual parameters. So when this is executed, these two actual parameters are associated with these two formal parameters. The first actual parameter associated with the first formal parameter. The second actual parameter is associated with the second formal parameter. And this time, we are passing the value of rad and area since there are no ampersand symbol, right? There is no ampersand symbol in this actual parameters. Unlike here, there is ampersand. So if there's no ampersand, we are not passing the memory addresses, but we are passing the values itself. And so rad is equal to, in here it's 3 and area is equal to 28.27. So the values of the formal parameters here are also associated with rad. So this is 3. And A is associated with area. We pass the value of area 28.27, and so A is also 28.27. And then we execute the printf. So what is displayed in here is the value of R, which is 3 and then 2 decimal places. And for this, we output A, which is this value 28.27. So that is the execution flow of the third program. So let's review. For this function call, when that is executed, the type of parameter passing that took place in here, what is the type of parameter passing that took place here? It's called call by reference. And call by reference means to pass the memory address of the actual parameter. In this case, the actual parameter is rad. So we pass the memory address, okay, because there is ampersand there. And so the receiver formal parameter in here, okay, this is the one we passed. This is the one we passed, ampersand rad, passing it to R. Since this is a memory address, R here should be defined or declared as a pointer variable. R must be declared as a pointer variable because what we pass to R is a memory address. So if we pass to R a memory address, then R is a pointer variable because its value is a memory address. That's why it should be declared as a pointer variable. And that is why we have here asterisk, because to make R a pointer variable, we have to declare it with the prefix asterisk, right, from our previous lesson. So since there is asterisk here, that makes R a pointer variable because what you passed as value of R is the memory address of rad. So it's like if this is rad, R is a pointer to rad. And so when we input here 3, this value 3 is stored not inside R, but this value 3 is stored in the, what is R? R is a pointer variable. This value here is stored in the address of rad. So 3 will be stored in the address of rad. So that's why we have here 3. And asterisk R is equal to 3. The value pointed by this pointer is 3. The reason why we use the parameter passing call by value at this point when we call input is so that the value that the user inputs here for radius will be stored in this local variable rad. Okay, that's the only way that the value will be given back to the caller by using call by reference. What happened here is like the main function having a container rad. This is a container or a variable. It's like when input is called, input function is called, it's like the main function gives away the container itself to input, okay? But this time, when the execution is inside input, okay, when execution is here, this container is called now as R instead of rad. Okay, this same container or memory location, when execution is inside the main function, this is called rad. The local name for this container or variable or memory location is called rad inside the main function. But when inside input function, this exact same container is no longer called rad, but it is called R. Okay, but this is exactly the same container. So when input function assigns a value 3 to this container, calling it R, input calling this one R, that same container, when execution is done here and execution goes back to the main function, this container now having a value 3 is no longer called R but called rad. Okay, so that is what happens when the parameter passing is called call by reference. If we change this one, if instead of passing the memory address, we simply pass rad, say for example, this is input rad, no ampersand, and so this is no longer a pointer also. This should be declared as just void input double R. Since this is a value, not a memory address anymore because we remove the ampersand, okay, there is no ampersand here, so that makes rad a value. You pass a value to R. So there must be no asterisk also because R is not a pointer. R holds a value, not a memory address, okay? Because it's not ampersand rad in here. We are not passing the memory address of rad. Instead, we are simply passing the value of rad to R. So what happens here is that in the main function, we have rad, memory location rad, a variable, local variable rad, and inside input function, we also have like a local variable r, and the value of this one is passed there, which is no value yet. So this would be an error in here, okay, because r is not a pointer, so there must be ampersand there. So if there is ampersand here, memory address of r, if the user inputs 3 here, then the value of this is 3, not this one, right? When execution is done in the input and execution goes back to the caller, what happens to rad? Is there a value assigned to rad? It's the same, no value, right? Because the input function puts the user input value 3 inside its local variable, not in here. And so when execution is over in the input function, when execution goes back here in the main function, there is no value inside rad. The value that the user inputs remain in the local variable r, which has a separate memory location separate from that, okay? While what happened earlier with parameter passing call by reference, these two share the same location. This location, say for example, memory address 81, is called by main function as rad, and when execution is in here, inside input function, this same container or memory location is called R. So 3 is placed here, not in here. Okay, these two are separate memory locations, while this one here is same location, same memory location shared by main function and input function. Okay, because you pass the address, not the value. So in this case, earlier, we call this parameter passing as, once again, it's called what? It's called call by reference, while in here, it's called call by value. So if you want a function to share the same location with another function, so that whatever value is placed in there, when that function is over, the next function will also obtain that value, then you need to use call by reference. You need to pass memory address as actual parameter, not pass a value. So in this parameter passing rad and asterisk r, this is called by reference, while between this one, function compute area, and this one, between rad and r, the parameter passing is called call by value. So in call by reference, the actual parameter here that is passed is a memory address ampersand rad. That is what you passed in here. And so the receiver formal parameter must be a pointer variable by putting that asterisk there. So between this, it's called call by reference. Between this and that, it's called call by value. And also for this output, when this output function is called, between rad and r here, it is call by value. Between area, the second parameter, and this one, it is also call by value. So let's compare the two types of parameter passing. First type of parameter passing is called by reference, and the second type is called by value. In call by reference, the actual parameter passed is a memory address, and that implies that the receiving formal parameter is a pointer variable. Another point for call by reference is that the value of the formal parameter affects the value of the actual parameter. Just like what happened in calling the input function, inside the main function, we have rad variable, and inside input function, we have r. So when we input 3, this becomes 3. So whatever happens to r happens to rad also. Why? Because they are actually, these two parameters are actually sharing the same memory location. It's like rad and r are both referring to the same memory location. Rad and r shares the same location. So when r is 3, rad also becomes 3. So again, rad and r share the same memory location. So one memory location shared by rad and r. That is for call by reference, where rad is the actual parameter and r is the formal parameter. But for call by value, the second type of parameter passing, call by value, the actual parameter passed is not a memory address, but it is simply a value. So if the parameter passing now is called by value, the actual parameter passed is a value, not a memory address. And the receiving formal parameter is not a pointer variable. It is an ordinary variable. And the value of the formal parameter cannot affect the value of the actual parameter. That is why if this is rad in the main function and this is r, formal parameter, in the input function, if it is now called by value, rad and r have separate memory locations. They don't share the same location. And so if r here becomes 3, when execution is over for input function and execution goes back to the main function, rad has no value because you place the value r in a separate container while rad has a separate container. If they share the same, like in call by reference, main function and input function shares the same location. In the main function, this is called rad. In the input function, this is called r. They share the same location. So inside the input function, when r becomes 3, when execution is over for the input function and execution goes back to the main function, rad has a value 3. Okay? This is the scenario for call by reference. This is the scenario for call by value. In call by value, rad and r have separate memory locations, while for call by reference, main function and input functions variables rad and r share the same memory location. So what happens to r happens to rad in call by reference. In call by value, what happens to r does not happen to rad. So when you go back to the main function, there is no value for rad because the input 3 remains in r. And so if you want 3 to be set as the value of the caller variable, then the type of parameter passing that you use should be called by reference. You pass the memory address. Okay, let's try to run this program now, the third program. The compilation is successful. Let's run this. Input 3. Okay, the output is 28.27. If we remove that ampersand, therefore this is not a pointer variable. Let's compile it. You get here an error. What is the error? Because in the prototype, this is asterisk r, so let's say we omit that. Compile again. So it is successful now. Run it. We input 3. Okay, that's the output. we have a logical error because rad has no value. The input value 3 remains here. It is not passed back to the main function, so that user input value should be used to compute the area and to display the output. So what is the difference now between program 3 and program 4? In program 3, the return type of compute area is double. And so when we call compute area, it returns the value of this expression to this part here, which will be assigned to area. And so that value here will be displayed here as output. In the fourth program, we change the return type of compute area to void. And so, because this is void, the only way for compute area function to return the computed value area, which is A, is to use a second formal parameter, which is a pointer variable, so that it could give out this value to the caller, which is in here. It's called in here. So what type of parameter passing we use here? Between ampersand area and asterisk A is called by reference. Notice in the fourth program, for compute area, we use the return type void and not double anymore. And so, this function compute area can no longer return a value to the caller via this return type because it's already void. And so, the only way that this function can give away the value of area to the caller is by using a second formal parameter A, which is a pointer variable, so that whatever is the value of this computed from here using that formula, that new value can be given away to the caller, and that will be assigned to area, which is a local variable inside main. So in this case, when this is called, notice that since this has no return type, we cannot call this function, the same way before by saying area gets compute area rad. We cannot call this function anymore, placing it on the right side of the assignment statement so that the value returned by this function will be assigned to area. We cannot do this one anymore. Instead, we just call it as a simple function call because it does not return any value at all. So this time, this is how we call compute area when the return type is void. When you run this program, this is first executed and execution jumps here in the input function. So rad and r shares the same location. Okay, this is rad/r. Rad is the name for this container inside the main function. This same container is called r inside input function. So rad and r share the same memory location. So whatever you do to r, making it 3, okay, inside here, if the user input is 3 for radius, then that will be stored in here. And when execution is over for input, that same container, which is called rad inside the main function, has the value 3. So again, between this and that, the parameter passing type we use is called by reference. After that, we call compute area. And between this one now and this, when we call compute area, the parameter passing use is called by value. And for the second parameter, this one and this one, between these two, the parameter passing we use here is called by reference. So area here, for the main function, this container is called area. Inside the function compute area, this same container is called A. So inside compute area, this is called A. Okay. Inside main function, this is called area. These two parameters or variables share the same memory location because you use call by reference. You pass the memory address, and so these two share the same location. So when computing this, the value for the first parameter, it is call by value. So take note that this function call compute area makes use of mixed parameter list. Why is it mixed? Because the first parameter between rad and r, we use call by value. Between the second, ampersand area and asterisk a, we use call by reference. So one function call, on the first parameter, what we use is call by value. On the second parameter, we use call by reference. So say between main function and compute area, they share the same location for parameters area and a. But for the first parameter, rad and r, in the main function, we call this rad, this container. In the compute area function, we call this r. So rad and r have separate memory locations or containers. In the main function, rad is this container. In the compute area, r is this container. Separate containers for rad and r because what we use here is called by value. While between area and a, the second parameter, area, and this one, what we use is called by reference. So this is called by reference type of parameter passing. So since it is called by reference, area in the main function and a in the compute area, okay, they share the same location. That's the characteristic of call by reference. So this same location is called area in the main function, and this is called a in the compute area. So that rad in the main function is 3. And so when you pass that value to r, that this is also 3. And then we use this value in here. Asterisk a becomes 28.27. So this is now 28.27. This is asterisk a. And when compute area is over, when execution goes back to the main function, the variable area has this value also, 28.27. Unlike in the call by value, when you change r, for example, to 7, say, you would say here, r gets 7, you change the value of r inside compute area to 7. This value, this change of value does not affect rad's value in the main function. Rad remains equal to 3 in spite of the change in r, because this rad actual parameter is not affected by the changes of the formal parameter r because they have separate memory locations or separate containers. While in the call by reference, when you change asterisk a, that would also affect the actual parameter area. So let's try to run the fourth program. Compilation is successful. We run it. Say we input 3. And there we have our correct output, 28.27. And the value we input here, 3, is value that we have here in the main function. This one is the asterisk r in the input. This one is the local variable inside main function. So we were able to get that value from the input function because we use the type of parameter passing call by reference.